to be getting into SOLIDWORKS first thing, and then after that I'm going to be handing it over to Danny, and he's going to finish it off for us in Mastercam. So without further ado, we'll get into how we can make your designs and things simple with SOLIDWORKS and Mastercam for SOLIDWORKS. So looking at that, why would we want to choose that? Why would we want to choose the combination of the best of both worlds? And that's a real simple answer. It's for speed. We also want to be able to make sure that we are fast, but also consistent at the same time, making sure that every time we do a design like this, it gets out the door and is accurate as possible. So the ease of use comes with the combination. You're able to use the leverage the power of SOLIDWORKS and the CAD environment that's very simple to use, as well as the Mastercam for SOLIDWORKS interface to get the toolpaths on correctly and very easy to use there. By doing the combination, we're going to reduce not only the manufacturing costs, but also the design costs as well, and make sure that everything that we put out the door is as efficient as possible. So what we're going to be talking about, the first portion of this, is the design process. And how we do that is we use a table, much like the one that you see there, to update a design. I'm going to use a 16.5 ASME flange. For you guys that are familiar with that, you're going to see a lot of the same numbers there. So we're going to go through the design, and we're going to start by one finished design. So we're going to develop one size, and in the model, I'm going to choose the 4-inch size to start with. Then we're going to go forward with an update using the table of dimensional values that we can source on the internet or get from our vendor or even get from our customer. And go ahead and put that and leverage the power of Excel to accomplish that. Beyond that, we'll validate the design, make sure that all the updates are correct, dimensional values are good, and then we'll go forward with the handoff to Mastercam for SOLIDWORKS, and Danny will take it over from there. When we design something, we want to go ahead and look, and this is the finished product of what we're going for. When we design it, we want to take an approach of how do we design it, how do we get that to go in correctly, and by doing that, we're going to create a revolve, and then we're going to do some other things. So I'm going to show you guys how to accomplish that straight away by just accepting a new design template. Taking that across, we can start with our Z in the correct direction in SOLIDWORKS as well, and go ahead and just design away. Now, a revolve requires a center line or something to revolve about, and that's the first step in the process. So once we get that far, we'll go ahead and then start to design the weld neck itself. We'll just design a few things as we go along, and if you guys see something that I'm doing that you want to kind of find out more about, don't hesitate to drop that in the chat, and we'll be able to answer that for you. But as we design, we'll take all of these automatic relationships and things that are happening in the design process, and we'll leverage that to create a finished design very quickly and easily. Now, what I'm doing is just drawing out an exact profile of what we want. The first dimension value that goes on might be this raised R value in our table. And by doing that, we want that to be, this particular value is 6.190. And in this case, I've drawn it to the half. So we'll make sure that we divide by 2. SOLIDWORKS has the power to leverage fractions, additions. You don't have to break out the calculator in order to accomplish any portion of the design process. We can leverage that as well. So taking this, we want to go ahead and put in RF1. Now I'm using the codes and I'm naming the dimensions as we go along, and that's so that the dimensional values that we understand from ASME are going to also be held and be there. So our thickness value, the next one that we need, pretty easy to do there. We'll go ahead and put 8.8. But if for some reason you forget, you can always open up that panel. You can always go through and relabel, redimension, and adjust anything that's necessary. Now, the few things else that I want to go ahead and accomplish here are just a few more dimensions. Let's go ahead and put in 2.94, and that is our weld neck length. So the length of the design there, great. Those are easy to do. Sometimes it gets inverted. We can go back and we can adjust the design, kind of reposition it. It's not a problem at all. We'll go through. I've got about 4 more dimensions or so that we've got to put in. Things like the bore size. weld bore, and that number. We'll go ahead and put that one in. Let's see. Now I'm going to continue putting in the values that we need, and as we go through this, you'll notice the ease of use is coming along. I didn't have to choose that I wanted a diametrical dimension there. It went ahead and did that for me. By taking that and using and leveraging that, it understands that I'm in kind of a mode in the process and I'm batching dimensions, and it takes that into effect as well. So now the last one, now absolutely not the least, we'll go ahead and put the OD on this. We'll make that a 9-inch dimension and mark that as the OD. So as we get finished with this, you'll see that SOLIDWORKS understands that I'm just about done, and down in the bottom right-hand corner, you'll see that right now it says underdefined. And as we go forward with this last dimension, you'll see that that number will change, or that name will change to tell me that I have every dimension that I need for manufacturing of this particular profile. As we go forward now, we can go and we can revolve this and take everything out to the third dimension. Go ahead and revolve the shape and create the basic shape for the weld neck. Now, the next few things that I'm going to do is I'm going to add a fillet to it. So this particular fillet adds an edge, but I could very easily add multiple edges in the same fillet if necessary, or even round off an end. All of that's possible within the design, so we can take all those values. Any one of the feature dimensions that we have, or anything that we need here, we can adjust also for dimensions by just taking a look at our feature dimensions. These dimension values for features are also in there. So in this particular case, we need to make sure that this particular fillet is marked as an R1 for our radius, and give the value that we need. So that's a pretty easy way to adjust the dimensions there. The last step in the process is to go ahead and put some holes on it. So we have a power in SOLIDWORKS to adjust and use what we call the hole wizard. The hole wizard can help us leverage design processes for screw clearances in loose fit tolerancing, or even close fit tolerancing. I choose the particular size bolt that I want to put in, and it's going to calculate the tolerance based on that. So when we position this, we want to make sure that we have a bolt circle first. That bolt circle is going to define where this is located in the hole design. Once that's done, we'll go ahead and place in our single top hole at the top dead center. Now, if you wanted that off at an angle, you could absolutely do that. Just dimension a few reference lines, and you're all set. This number is 7.5, and we want that to be the bolt circle, so indicating that as well. So I'm almost done. I think we're pretty close to being finished up with the weld neck. The last step in the process is to take this circle and have it come across in a circular pattern. So we can make choices as to how many holes we want, maybe a dozen, 8, I think is the right in the specification, the number. But it's very easy to go ahead and adjust that and have that finished design complete very, very quickly. Now, that's the first step in the process. Once we get done with the design process of just the first component, and this is the 4-inch weld neck, I want to go ahead and get maybe a 5-inch or a 6-inch or an 8-inch, whatever the number is, right? So in order to do that, we're going to start with this default configuration, but I'd like to go ahead and add an additional size. Very easily, I can say second size, and this isn't going to be complete, but I want to show you that we can vary individual sizes depending on what we want to adjust. So, for instance, if I wanted to adjust the overall 9-inch dimension from one to another, I can very easily just manipulate the dimensions within that particular design and say, you know what, I want this one to be 10 inches, for instance. So once I do that, you'll see that I have a variance. I have 2 different configurations or variations of this particular component. I have my default and I have my second size. So what we're going to be doing today is we're going to be using a design table to drive this change. By doing just that little bit, I've been able to create a second size, but we want to expand on that. We want to do the entire table all at once. So being able to do that through a design table is the way we accomplish that in SolidWorks. When we select the design table, it's going to bring up a set of choices for me for bringing in the OD dimensions. If I wanted to add a third size, for instance, we could go ahead and do that as well. Now, all of the dimensional values that we put in, we could say, you know what, the OD is 12 on this particular one. What's going to happen is it's going to generate a third set of dimensional values for me and be able to put that third size in. Now, all of it is table driven at this point. This particular design table, if I go back and edit it, it would potentially collect some of the information. Now, what I'm looking to do is I'm looking to grab additional dimensional values within my table. So I'll need to go through and collect some of the other annotations and values that we want. So using our feature dimensions like this overall bolt circle, as well as the 10 dimension that we already have in the table, all of these dimensional values can be brought into our table very, very quickly and easily by editing the table and just double clicking those dimensions. Now, let's get in there and just add one more or two more so you guys can see kind of how this works. When we add these dimensions like this thickness or the weld neck, you see how easy that is to kind of configure and add additional geometry and dimensions to it. Now, what I'm looking to do is I'm looking to get all of this in a certain order for us so that we can bring in the entire table. Now, not to waste time kind of going through the process of getting all the dimensions in the correct one, I've staged up a drawn part here that is exactly that way. It has the table kind of finished out, ready to go for import. And what we're going to do is we're going to take a Excel table that is for the flange that we kind of sourced off the manufacturing or off the internet or off ASME, and we've gotten that data. So the data itself comes in something like this. We have all of the tags that we put in for the dimensional values, and we'd like to go ahead and develop our system for 4 through 24 inches, right? So I need to take this data and copy it directly from Excel and take that and put that into our table. I've been able to take a multitude of pieces of information and be able to develop that. Now, what's going to happen when I exit the table is it's going to say that I've developed 4 through 24 configurations all in one shot. Now, this design table set of configurations has been developed for me. The last step in my process might be to reorganize it a little bit. I might want to show them in a numeric value list so that I go from 4 to 24. I can also select individual sizes to verify that, sure enough, yes, absolutely, it's the right size, it's the way that we wanted it in the particular design, taking those and adjusting those, measuring individual component sizes. You can see the diameter of this particular size is 25 right here in the bottom right. So at this point, I'm ready to transition and take this from a design realm into a manufacturing realm. And that would be the use of Mastercam for SolidWorks. So I'm going to take this, I'm going to hand this off to Danny, and I'll email it to him, or maybe we'll have a network share or a PDM system. We'll go ahead and do a transition from the design side to the manufacturing side. So Danny, if you wouldn't mind taking over the presentation and kind of starting with our design, we'll get on to the next phase of this.
I sure will. All right, welcome everybody. So Stephen emailed me the part. I have it right here. I've opened it up in SolidWorks. I'm going to get right into this. The first thing I want to do is, by default, I have a mill set up. So I'm going to do a few extra little steps, taking Stephen's work here. The first thing I'm going to do is I'm going to edit this table in a new window. And I'm going to go ahead and cut this for the time being, because I want to reassign everything to a lathe profile. I'm going to temporarily go ahead and get rid of these these configurations. Sorry about that. Then on Mastercam, I'm going to go ahead and make sure that I'm in a lathe mode. And I'm doing this so all the dimensions that I'm going to be when I look at those dimensions, they know they're in the DZ configuration versus XYZ for a mill. And I'm gonna go ahead and remove my mill. And the plane, the way the part is set up is not configured for a lathe. So I'm gonna just simply take this plane. I'm gonna copy him, rename him. I'm gonna go ahead and move the origin to this face right here. That's where I'm gonna start my part when I put it in the machine, in the lathe. Then I'm gonna go ahead and set up that work coordinate. So I got my work coordinate in the diameter and in the Z for a 2-axis lathe. Select OK to this. While I'm at it, I'm gonna go ahead and just make some quick modifications to his sketch. Let me flip him around a little easier so I can understand that it's coming from the lathe here. I'm going to add 2 points. Now we can add this to the design table if we wanted to, but for today, I'm just going to sketch them up here. I want to add a few dimensions. This is what's going to help me drive a facing operation. And these dimensions will be changed, will change as we change the part as well. All right, select OK to that. Go get this sketch here. Now, so I can show you, I'm going to go ahead and make this visible for the time being. In my lathe, I also want to make sure that I'm in the right construction plane. Go ahead and set it to lathe here. While I'm at it, I'm going to edit the machine here. So I have a machine that has all upper, left spindles, right spindles, upper and lower tools. I'm just going to use just this left spindle group today. And I'm going to adjust the max RPM for this chuck and just say 1,000 RPM. Select OK to this. Go ahead and say OK to the whole thing. And I'm going to put just a few simple little toolpaths here. So first thing I want to do is I want to put a facing operation. I'm going to grab this tool here and selecting my points and selecting the points that I created on that sketch. As the volume that I want to face off, I'm going to go ahead and do a roughing operation or a rough step over. No need to finish past this. And I'll select OK. I can go ahead and say backplot this, and it shows me my tool. It'll come in. That'll be the raw material. It'll have an ID, so I don't have to go all the way to Z0. I'll select OK to that. Let's go ahead and hide him again, kind of clean things up. Now I'm going to go ahead and do a roughing operation. I'm going to say rough, and go ahead and I'm going to pick that sketch again. In Mastercam for SOLIDWORKS, is going to create 2 chains here. In other words, I have 2 options. Do I want to go ahead and bore the ID, or do I want to cut the OD? So I'm going to take this one, delete it out. Then I'm going to modify this one. I'm going to hold this part somewhere on this upper flange. So I just wanted my tool to stop right here. I'll select OK to this. I'm going to select the same tool. I can even force an operation or force a tool change. Give it a comment for your machinist to understand what's going on. And let's just say on the exit, I'm going to go ahead and extend it out that same 1/4 inch that I defined with that point. I'll select OK to this, and I have my roughing operation. Go ahead and clean this up again. I'm going to turn the display off. Now I'm going to go ahead and drill some holes here. These the bolt hole. We'll go ahead and do a C-axis face through. I'm going to manually select my points. Okay, I'm going to confirm that my points are in the center. They look good. I'm going to select OK to this. I'm already in the right construction plane. Mastercam is intuitive to know that it's going to go ahead and that I'm changing the direction of the tool. I'm going to go ahead and select the tool from my library. I'm gonna grab a 1/2 inch drill. Do a pecking cycle. Give it the pecking amounts. Allow for tip comp to make sure that it breaks through. And then my linking parameters, I'm gonna give it plenty of room for it to retract out. So it's gonna, everything is set to incrementally from wherever the feature is at. And I'm gonna go ahead and set my depth and tie it in to this back face right here. So as the part changes in the design table, this value will always change as well. I'll select OK to this. And I can go ahead and backplot that. Now it's gonna go ahead and drill those holes. Now I'm gonna go ahead and finish them to size. Let's go ahead and do a helical bore so we can finish them. And the same thing, I'm gonna go ahead and pick the edges of the holes. I'll select OK to this. Now, since this is a milling operation, I'm gonna double check here, and I wanna make sure that I'm in the, I do pick up the C-axis plane. And then the same thing, I'm gonna set everything to incremental. My depth, once again, to this back face, 1 inch, incrementally from wherever the feature is at. In my cut parameters, I'm gonna go ahead and enter in at a 45-degree angle. I'm always gonna start at the center, make everything to size. I'll answer that phone call in a little bit. I'll select OK to this. And then I have my, oops, you know what? It automatically picked me a tool. Let me edit that tool. I'm going to extend them out just a little bit, a little longer here. Update that toolpath and see how easy it is to just go back and change, any information that you're doing for your toolpath. So now it's going to do, the finished diameter of the bore. And as the bores change, it'll change as well. So we'll go ahead and click OK to this. So I've got the first part set up. These are the toolpaths I want. Now let's go back to that design table here. So I'm gonna go back to this design table. Now I'm gonna go ahead and repaste everything back in here. I'm gonna save it. So now it recognizes these values in this new plane. So now it's gonna say, do I wanna copy all the toolpath information that I put onto this on the default part? I'm gonna select OK to this. It's asking me if I want to do it to all configurations, and I'll select OK. And like Stephen, I've updated, generated a new configuration table here. So here's all my parts. And I also have a quick utility here. I'm going to go to my utilities. This is where it comes, as Stephen mentioned, for speed, consistency, accuracy, and all this other, what we talked about. I want to go ahead and regenerate all the configurations at one time. So what Mastercam is doing is reading these configurations and applying and updating all the toolpaths for all the sizes of these weld neck flanges. And I was able to do that with just one button here. All right, so let's check this out. So I'm going to go back all the way to the 4-inch one here, show this configuration, smaller one. I'll go back to my Mastercam toolpaths. I can backplot that. It shows that it's cutting that part right there. Okay. Let's go to a different configuration. Let's go say the number 8 right here. Say show this, little larger size. Go to the Mastercam tab, and the toolpaths are associated to that size. So it was all the work Stephen did up front, made my job very easy. Okay. And I don't know if we're answering questions or not. Who's monitoring? I can't see if anybody has any questions or not. Okay. So I'm going to talk a little bit about, so at this point I can go ahead and, post it out if I wanted to. And I would get code that would be for that particular machine. And I could post them all out for the different changes. There's my code right there. Roughs it out. There's my C-axis drilling. And then there's the helical bore right there for each of the holes.